Hello and welcome to the section 7.4 lecture today for Algebra 1 Part 2. Today we're looking at composition of transformations. And it says today that I can graph and describe a composition of transformations. Well, what does that mean? Composition. Well, we know transformations are, something happening to a graph. Okay, we're changing a graph somehow. And that's one aspect of what we want to do. When we're talking about a composition of transformations, it's a fancy way to say multiple transformations in a row. So I'm taking the same shape, the same points, and doing multiple transformations at one time. Now, not really at one time. I am going to be taking my time to do these. And one of the most common is what we call what we've kind of informally named as a glide reflection, which is what we're going to look at in the first two. But we're not just limited to that. A glide reflection is the combination of a translation and then a reflection. Think of like footprints in the sand as the most common theme, the most common example of a glide reflection, because it moves and then flips over for the other foot. And then it moves and flips over again for the first foot. So what we want to do here is work out all of our triangles and work out all of our transformations that are happening step by step. For this first one, let me start with the pre-image of 1, -4, 6, -4, and 5, -1. And at this point, you kind of have an option. A lot of times, knowing what the end goal is, I typically will not graph this first triangle. I might just keep it as points because I know that I'm going to do some stuff and then I'm going to have to regraph it. But it's okay to do that. It's okay to graph it and draw the lines. I know it's a little bit more entertaining, I guess, to graph the the shapes and think about moving the shapes rather than moving the points. So I'm gonna perform a translation along 2, 0. So I'm changing my x coordinates right 2. That's what translation of 2, 0 means. So I'm taking r, moving it 2 units. S moving it 2 units. And t moving it 2 units. At this point, I get r prime, s prime, and t prime because I've done something to each of those points. Okay. Now it says I want to reflect it in the x-axis. I want to look at its reflection in the x-axis. That's the horizontal axis. And so r is 4 units away. Sorry, r prime is 4 units away, so I'll move 4 more units away. And I'll get r double prime here. S is 4 units away, move 4 units away perpendicularly, we get s double prime. T is 1 unit away, move 1 more unit away, and get t double prime. And that is a very small, but it works, glide reflection. Okay. In the next one, I have the triangle at 1, 3, 5, 0. Oop, that's 7, 0. 5, 0. And 7, 4. we'll go ahead and graph it. Like I said, there's a lot of times that I probably wouldn't actually draw the lines to my pre-image just because it muddies it up a little bit, right? And I'm going to put the points on here. Sometimes I might not, but this time it's just as good as any. Let's see, that's L. Okay, I'm reflecting it along, or sorry, I'm translating it -3, 0. So that is a horizontal move, left 3 units. So J is going to move 1, 2, 3 units to give me J prime. L is moving 1, 2, 3 units for L prime. And K is moving 1, 2, 3 units to be K prime. This is going to get a little bit messy. Actually, I do want to put those in a different color to help them stand out a little bit. So let's go back to red. So 1, 2, 3. 1, 2, 3. And 1, 2, 3. So that's J prime, L prime, K prime. I'm just going to leave those as points for right now. I'll connect the triangle once I do my reflection. So for my reflection, it's in the x-axis. L is 4 units away, so I will move 4 units the other way for L double prime. J is 3 units away, so I'll move 3 units the other way. Get J double prime. K is actually on the mirror. We talked about this before, as like if you touch the mirror, there is no difference in the two locations. You're touching the same spot. So K doesn't actually move. K is, pen's lagging. Come on. So K double prime is going to be right where K prime was. That's okay. Everything works out just fine. So that's where our final product lives. That's where our final image lives. Okay, now we have some other ones. Those first two were true glide reflections in that we translated and then reflected, but we're not limited to that. We can do anything. Okay, we can combine them in any way that we could ever think of. These ones are just line segments, so it's a little bit less to work with, which is okay. W is at -4, 6. -4, 6, that's where W lives. Of course. And X is at -4, 1. We want to reflect this in the x-axis. I'll switch colors again. I want to reflect it in the x-axis. So X is 1 unit away. So we move 1 unit the other way. That's where X prime is. And W is 6 units away. So I'll move 6 units the other way. That's where W prime is. Okay. The next one talks about a 90-degree rotation. If they don't give you a direction, that has to be counterclockwise. Wait. No. Sorry. It is counterclockwise. Sorry. I was thinking the right thing, but not saying the right thing. Okay, meaning this way. This is a standard rotation direction. Okay, so I want to move it. I want to rotate it 90 degrees. Okay, 90 degrees counterclockwise. If we go back to our rotation rules for our coordinates, 90-degree rotation counterclockwise. So I messed this up here, but that's okay. That was That was an old day. I've probably fixed that mistake by now. So 90 degrees counterclockwise. Oh, no, that is right. Sorry. 90 degrees counterclockwise takes xy to be negative y, positive x. So let's get to that. Oops, too far. So this means we're going to take xy to negative y, positive x. It might be useful to have my coordinates of these points so that I can actually do that. This is at -4, -6. And this is at -4, -1. Okay, let me rewrite that. But I'm going to write it on the other side because I'm moving it that way. So it's -4, -1. Okay. So just we'll look at x first. We want to take the x coordinate and move it over, and the y coordinate, move it over and make it positive. So that's going to be -1, -1, -4. Sorry, +1, -4. Again, thinking the right thing, saying the wrong thing. That's going to move to right there. Yeah, switch the sign, keep the sign. Okay. Then w is going to turn into +6, -4. So it's going to move right here. So it'll be x double prime and w double prime. And that is our final product. Okay, let's look at this one. I've got a at -3, +2. That's point A. And then at 3, oh boy, 3, +8, way up here, is B. So that's my pre-image. I want to rotate it 90 degrees. So I'll do the same transformation, and then I want to translate it later. So let's rotate it 90 degrees. So -3, +2 turns into -2, -2, -3. And this will turn into -8, +3, using my rule right here. So -2, -3. Let me switch colors. -2, -3. And -8, +3. So this is B prime, and this is A prime. Okay. Not a great straight line, but I did my best. And then I want to translate it along 4, 4. So I want to go right 4 and up 4 with each one of these points. I could do that coordinate-wise, or I could just count it off. 1, 2, 3, 4, 1, 2, 3, 4. That'll be A double prime. 1, 2, 3, 4, 1, 2, 3, 4. My recommendation to you is to move all your points and then actually label them so that you don't put a label somewhere where you're actually going to put a line. That can sometimes mess people up, and then they draw through their label, which then they don't like. So put the points there and then put the labels. I was able to do it because I had a good idea of where it was going to go, but you see even here I almost wrote over my A, which I wouldn't have liked. Okay, so that is our composition of transformations, and yeah, hopefully that made some sense. If you have any questions, put them over on the left, and then also put them into the assignment that contains this video. You are getting points for putting questions in. If you don't have a question, just put everything made sense so that I still know that you watched the video. That being said, I hope you have a great day, and we will see you in class.